It's wonderful to be here with the panelists of today, to be joining with the participants, and of course, those of you who are watching this session live through Facebook. I'm Christina Rebel. I'm co-founder of Wikifactory and the co-chair today of this Viral Response Roundtable. Today is actually a very special session because I have the opportunity to co-chair the session with Madelynn Martiniere from Uncompromise. She'll be introducing herself shortly. To give a bit of a background to these roundtables, we started to host them at the start of May, when we felt there was a need to deepen the discussion as to how we can bring community together, diverse communities together, to share insights and learnings so that we can actually build collaborative innovation networks to resolve our current crisis today, in the medium term, and in the long term. The first session, we had the opportunity of bringing different projects that develop PPE, ventilators, medical devices, built environment solutions in front of experts. And that paved the way to some of the key questions that we wanted to deepen the debate in. We've covered questions like how to build collaborative communities, how to audit and secure accreditation for the hardware supplies that the community is developing, through to what are the funding opportunities for these projects to accelerate. But today, I think the question that we're going to be tackling, the question of how to distribute the fabrication of COVID-19 hardware and medical supplies, is perhaps the most important one. And because there's so many diverse perspectives that we need to bring to the table to actually answer that question in a holistic fashion. And that's why I'm delighted to be here today with these panelists. I'm here with Mark Freedman from Tulip and PPE Logistics. I'm here with Golan Landsberg from HP, with Häuer from OSEcology and Open Know-how, Karim Asry from Espacio Open, and Tom Salfield from Wikifactory. And these panelists will all be given 5 to 8 minutes to give a presentation and share their perspectives and insights on this question. And we'll be following this presentation session with an interactive Q&A. This Q&A session is going to first be chaired by Madelynn and myself. And of course, we will lead it on to any questions that you might have as participants or even watching through the Facebook Live, because we really hope that we can create an atmosphere of dialogue. And that's why we'll also be sharing a few polls. We appreciate in advance if you can help answer the polls. And of course, we're going to be documenting the whole event through Twitter. So do follow us on Twitter with at Wikifactory and using the hashtag #ViralResponse. I would like to give context as to why I brought Madelynn here. About a year ago, almost, we had a summit over in Copenhagen at the Tech Festival Summit. Basically, we called for an internet production at a summit where we brought together diverse minds to discuss, well, how can we, learn from software and build an internet production? And Madelynn was just a fantastic facilitator of our summit that day. And when we were tackling this question of distributing fabrication, Madelynn came to mind because she's been a profuse community organizer at the other side of the pond. So I'm based in Europe, and Madelynn has had a decade of experience over in the US in terms of distributed manufacturing. So I would like to give you the word, Madelynn, and warm up this session before we introduce the speakers here.
Thank you, Christina. And it's so great to be here. And I feel like I've been on a journey with you and with some of the other folks on this panel long before COVID-19. So it's great to be here with so many familiar faces. A very brief note about Uncompromise. So we are a distributed systems change consultancy, and so we are working with a very diverse group of people, some of which who are consultants and entrepreneurs, technologists, academics, economists, who are trying to understand and grapple with how do we address some of the world's most complex challenges. And so there's a variety of meaty challenges that we're looking at, from water and sanitation to healthcare to hunger, and manufacturing and has come up repeatedly, and particularly in light of the current crisis, which while no one wants to be in the situation we're in today, is actually been quite lovely from my perspective, to be tapping into some roots, as Christina said, as a community organizer, but first and foremost as a maker. So I started my career working with the maker movement, building hacker spaces and maker spaces, primarily in the US. I filmed a documentary around maker spaces in the US and the world. And then I worked very closely in the manufacturing and distributed manufacturing industry. So I've worked with many large players. I was director of community at a company called Fictive for several years. So I've been living and breathing distributed manufacturing for years. And so now these worlds are colliding as we're trying to understand how do we leverage the tools, technologies, and the people and these human networks to addressing these shortages in a way that not only supports what we need to do for this current wave of the pandemic, but the next, and we know there will be a next, or if you're in the US, it's going to keep on rolling, and for the next crisis, because the challenges that we're facing from a distributed manufacturing perspective and production is not new. So these opportunities that we get to come together as a community and grapple with the complexity and figure out, well, how can we collectively do better together? So I'm excited to be here with this great group of panelists.
Fantastic. And that international edge, this, together, I feel we pretty much cover the breadth of the globe. Wikifactory is based in China and Asia, as well as in Europe. And with the panelists here, we cover a broad region of the world. And it was actually coincidentally in a session, I'm going to actually call out the Fablab network, because actually in the session that the Wikifactory gave at the very start of the confinement, at least in Spain, for us, we gave an incredible talk with the Latin American network of Fab Labs. And during that session, there was Espacio Open. So it wasn't Kareem, it was his colleague Nerea from Espacio Open that was there that day. The session was about what can Latin America learn from the experiences of the maker movement in Spain, seeing that we were 2 weeks ahead. And the story of Espacio Open completely blew my mind. Quite frankly, Karim, the organization that you have done as a node, connecting the different fabrication services in response to COVID was phenomenal through just a spreadsheet. So I would love to give the word to Karim to start the presentations. Karim leads Espacio Open, one of the major maker and Fab Lab spaces of Spain. Also the organizer of the Bilbao Maker Fair, the biggest maker fair in Spain as well. And it's just a pleasure to have you here, Karim. Over to you.
Thank you, Christina. Thank you, everybody, and happy to be here in a moment that is also good to remind of the very, very scary and dystopic weeks that we live. It seems like it was a year ago now that we are recovering some kind of normality, actually. So I'm gonna start sharing my screen. But basically, our story is probably no different than anyone that happened in all Fab Labs and maker spaces all over the planet, where we basically kind of rose to the occasion and became from one day to the other the largest manufacturer of emergency protective equipment in our area, to try to protect as many people as possible in a moment where there were no face masks. Face shield was just a niche thing that was used by dentists in their in their procedures, and we didn't have ventilators. We didn't have a whole set list of things that were basically life and death questions at the moment. So this picture that you see right now is an image from our space in the old Wikifactory where we have the Fablab. And basically the woman that you see behind us is Merche. She's a doctor in the health center in the neighborhood of Recalde, my city, Bilbao, in the north of Spain. And I didn't know she was coming. She basically heard from another doctor that we were distributing face shields, and she came at 9 o'clock in the morning with her tub and with a question: can you give me face shields? I'm gonna have COVID patients arriving this afternoon, and we don't have nothing but these face masks, and we don't even have enough of them. We're gonna have to reuse them for at least a week or so. She took a bunch of them. She sent somebody else. The guy that you see on the right, he's an ambulance driver, and basically it was the same story. So what we did is basically reconvert a space that was closed during the pandemic because of the lockdown into an emergency 24-hour personal protective equipment facility where people could come and pick up what they needed as fast as possible, because it was all about acting fast. Now that you see that the worst is kind of behind us, hopefully. Now, the other day I was at the grocery store and I saw this stack of face masks and even the face shield in a very, very similar design that as the ones that the community made, but now that were made by traditional companies and with other procedures that can scale faster, like injection molding. So the key question is, what was our role here? And it was probably to do the transition between the chaos when something as scary and fast as a virus spreads out, and the time of transition that large institutions need to write their program somehow, because large institutions need a program to run to face any type of problem. And the maker community and the Fab Labs, what we're good at is basically writing that program on the fly to try to find a way to keep solutions. So we worked on the different layers of networks we're involved in: the Fablab network, the Spanish network, and there's this specific network that was born during the pandemic called Coronavirus Makers, that started as a couple of WhatsApps and Telegram groups, and it became in a few days a 16,000 people volunteer organization that was manufacturing hundreds of thousands of emergency PPE equipment. And these are just some quick figures from the trenches in Bilbao to give you a little glimpse of what happened. We did around 8,000 units of face shields. We printed some non-invasive ventilation valves for the Basque government and other hospitals that were asking for these connectors that were 3D printed with FDM, and then some intubation boxes and tracheotomy boxes with the laser cutter. Everything started basically from this emergency that we needed to act, and we had kind of like the tools and the expertise, and specifically the knowledge and the brain power, the collective brain power that the internet gives us, connecting one another to be able to act as one, to try to tackle something as deadly, as fast as a virus. So we started organizing different conversations to research on materials, to research what's available, what's not. We were actually working on 3 different type of material designs in case we run out of acrylics. Everything was so dystopic that we were calling our suppliers and we were running out of metacrilato. So we were also trying to find ways to do alternative things in case we ran out of it, like with cardboard or polypropylene. And we started finding a way by, of course, we didn't have time to do anything that was homologated or to go to any type of bureaucratic process at the emergency at the beginning of the pandemic. So the validation process was basically having a feedback loop from people who were at the front line: hospitals, doctors, nurses, and people who were actually using these materials. And what we did is try to keep it simple and try to use materials that were already used in hospital environment, and try to improve the designs as fast as possible through the validation process with medical experts. In parallel, we did open a door and a process to do official validation of some of the designs. some of the community designs actually have been validated. The coronavirus makers collective is now very close to do a silicon rubber ICU degree level protection face mask that is validated by the Spanish authorities, and there's several processes that go on at the same time. So one thing doesn't say, I mean, you shouldn't have to ask yourself whether you have to validate or not. Of course, it's something that you have to do, but in the meantime, you have to act fast to protect as many people as possible. So what we started doing is trying to manufacture with the processes that we had. Of course, 3D printing was where it all started, but laser cutter was a tool more suitable for the occasion, and it allowed us to go 30 times faster than with 3D printers. The picture that you see on the left is elder care home nurses here in Bilbao that were doing the assembly to go fast. What we were doing is basically providing a DIY kit and some instructions with a video tutorial for people to assemble it. And then we started trying to find ways to scale up. Once we had a product and once we had materials, what we needed is partners to make more and more of these face shields that were becoming something that had an infinite demand with very, very limited resources. So we started picking up the phone and calling people that we had good relationships with, like this public artist center in our city, Bilbao Arte. We started calling artists like Tunipanea and Real Cuba, but also traditional companies that we were contacting through the Companies Association of Bilbao Vizcaya. And they were also very, very helpful, helping us get the supplies needed to finish the face shields, like the PVC sheet that was used usually in contexts like leather press companies and things like that. So we got a bunch of companies, a bunch of artists, and we started acting as a connector to prepare, verify, and distribute these distributed factory that was basically working 7 days a week, 24 hours a day. Doctors or elder care home people will call us at 10 o'clock at night. We would have somebody at the factory doing the night shift with the laser cutter, and they would be delivering the package. We had to change the process on the fly because at some point we realized that the health of the people that was coming into the space was deteriorating super fast. They were coughing, they had symptoms of COVID-19. So we realized, okay, maybe it's not a good idea to have them enter the space. So we created this quick pickup spot where we would leave a bag with the supplies that they asked for, and they could come at any time of the day and pick it up on car, and we would reduce risk for our people and for the people that would be around at that point. We also worked on trying to build some kind of citizen logistics platform to get the supplies, to get the pieces to the hospitals, and it was quite amazing. Now that I rethink about it, we were all acting as one from different backgrounds. We had people from companies, from arts, from government officials, and it's quite amazing that when we have this common enemy that make us, forget about bureaucracy, forget about let's say core procedures, and just focus on what's important, getting as many PPEs on the streets as fast as possible. And I don't want to go longer than expected because I think the conversation is going to be way more interesting than what I'm telling you. But just to give you a quick glimpse, we made more than 8,000 units for 70 collectives. This is something also that was quite unique of what happened here in Bilbao. At some point, the Basque Police Union contacted us, and they were needing 3,000 face shields for street agents that were quite hysterical, actually. And we were supplying the doctors and the nurses and the elder care home. So we were like, okay, we cannot do it right now, but we can give you a template. We can give you a design that you can take to a laser company and manufacture. And then you can do the assembly yourself. So they basically set up a factory of face shields in the union office that they have here in Bilbao, and they manufactured more than they needed in a few weeks, and they were also supplying other police corps in record time. So not only we try to convince people that, you know, we shouldn't say, okay, we cannot buy them, we cannot do nothing, let's just stay away at home and wait for this to go away. But we also wanted to show people that they can also become makers if they had the proper tools, the equipment, and the templates that they needed to do it. And it worked. It didn't work perfectly, but I can only imagine that the situation here in Spain, that has probably one of the highest deaths and infection rates per million habitats in the world, and we also suffered one of the most medieval lockdowns in the world. The situation would have been way worse if we didn't put that close to 1 million PPEs in the streets in the first weeks of the pandemic. And then after a month and a half, let's say that the infantry comes in and companies can scale up production, inspired in the designs that were made by the maker community that kind of did these heavy lifting of the beginning of the pandemic, figuring out which are the designs that were more suitable for the front lines. And then what we started doing also is connecting with other countries that weren't still affected by this pandemic, to tell them to get ready. In this talk that we had with the Peru community in the end of March, I think Christina was among them, and my colleague Nerea tried to make them understand that this was coming, and it was big, and it was important, and it was a moment for the maker community to rise up to the occasion. And I don't want to extend too much, so I think I'm going to stop here. But I really feel that the question that I feel that is still in the air is that what the Fablab maker community and the open source movement in general did is react faster than any other institution on the face of the planet. No? So this is something that is super important, but it's also something that is very hard to find a way to encapsulate into a process that a large organization could deploy as fast as the maker community did. I mean, if you think about it, 30 years ago, only multinational companies like Coca-Cola or Procter & Gamble could deploy a product on record time in all the corners of the planet. Well, right now, thanks to the internet and all these amazing set of people that are sharing their tools, their knowledge, and their expertise, we have this network of human beings that can deploy without having a business model behind it, basically prototypes of almost anything, which is also the interesting. Probably we will never see another pandemic where we have to do face shields, because now face shields are commercially manufactured by companies who are already very good at it because they already have their networks. But who knows what the next big crisis will be. And I really feel that this network rose to the occasion, and it's probably one of these things that are going to make our societies more resilient and more resistant to the whole bunch of unexpected dystopic things that could happen in the following years. And I think that will be it, and let's let somebody else talk about. I'm really interested in hearing other type of organizations' perspective on the pandemic.
That's a fantastic story, and we will be digging in, I am sure, to so many things that you said there. I will hand the baton over to Mark. You know, I had the pleasure of meeting Mark a few weeks ago now, I think, though COVID time, a few weeks feels like a year ago at this point. And met Mark when some of my colleagues and I were trying to understand, well, how do we best connect up so many of these disparate groups and communities that were coming together to address COVID-19 and the shortages of PPE, and particularly focusing on the logistics and supply chain. And had after weeks of talking to a variety of organizations and maker spaces and understanding the state of things, and we started thinking about building a platform to help support that. And then we found PPE logistics, which we went, great, we don't need to build this, it already exists. And I, I'd heard of Tulip in the past, and was very fortunate to get a tour of the platform, and I have just been blown away both by the modularity of the platform and how it's been constructed for scalability in a way that can really support a variety of organizations and networks, and how quickly they have applied that to the problem at hand around the shortages of PPE. So we had a great time geeking out on a phone call about all the different things that it does. So I will stop there, and I will let Mark share the great work that they're doing over at PPE Logistics and Tulip.
Thank you for that introduction, Madeline. I think what I'd like to do is just kind of try to first answer the question that was posed as concise as I can, and then maybe share with you some slides about what we did specifically in this world. So the question was how to distribute fabrication of COVID-19 supplies. And just a little background on myself, I'm actually a manufacturer, not really a programmer at all. My background's in manufacturing and lean manufacturing, continuous improvement, these sorts of things. But to answer that question, I don't think we're just talking about distributing fabrication. We're talking like people are capable of manufacturing things. Kareem just showed people these days have the capacity to make all sorts of wonderful things and have the ingenuity and resources to do so. But if I were to download something myself, I have a 3D printer in my room over there. If I were to download something and make an accredited product or something, what would I do with that? Who would I give it to? And how would they know that I have it, right? So I think it's more about enabling a distributed, not more about, but it's equally about enabling a distributed supply chain network and like systematically unlocking all this capacity that previously was not recognized or within that chain. So how do you unlock that? How do you realize this capacity? And I think that's a really interesting challenge. And I think we're well positioned to solve that challenge. And I can show an example of what we did to help with that. But there's a lot that can be done. Current supply chains. My cousin, she works in healthcare. She relies on some well-established supply chain that's global, that has maybe 3M having a factory somewhere, reducing costs and sending over millions of PPE and these sorts of things. But that obviously broke down in this scenario. So like I like to think in analogies. The analogy I use here, or I'd like to use in this case, is kind of silly, but like it's kind of like a pizza place. So this pizza place is making pizza for like these two organizations in their local neighborhood. They have a delivery driver. This is the established production chain that they've created, the supply chain. But suddenly everybody around them wants pizza, and their one delivery driver cannot support this. The people who want the pizza don't even know this place is making pizza. And people around them have ovens and could make pizza if they wanted to. So that's like the challenge that I see is how do you basically enable this connection in a systematic way that lets you, I need pepperoni, this person has it, let me get some of that from that person. And you can like suddenly leverage this network to be a supply chain that works better than the traditional ones that are like well forged, right? And what I would use as an example of maybe what we could see right now that looks like a potential future state is something like a Grubhub, which is why I use the pizza, right? If I want pizza, I just type in pizza. I see a bunch of different people making pizza. There's reviews on them, so they're like qualified in some capacity. And when I want the pizza, it's a distributed network of drivers. And those people can you don't know who the driver is and you don't really care because it's the system that enables this unlocking of potential. And I think that's the situation that we're sort of seeing here. So let me show you an example of what we did. I'm going to share my screen here. But that's sort of my answer to the question. And let me share this example here. I should, since Madeline mentioned it, and I do work for Tulip, I should mention quickly what that is. So I'm going to skip through some of these slides, but basically Tulip is a platform that takes this idea of democratized, like distributed networks and such, and it uses that in creating software. So anyone who is not a programmer like myself, for example, can create applications very quickly. You see here is an editor. You can drag and drop. It's like PowerPoint sort of. And people are naturally using these cloud-based systems. Like a lot of these people we talk to are using Google Sheets to manage their networks. This is something of that nature, except it's scalable in the sense that it can be connected to your ERPs. It can be connected to other information systems and so forth. But you can change it rapidly. And as a lean practitioner, I'm a huge proponent of rapid change. So we can connect to devices and these sorts of things, but this isn't a Tulip ad. Here's what we did with Masks On. We joined a Slack channel, which is a network of people, 3D Core originally, and Masks On was trying to basically build retrofit scuba masks with 3D printed adapters so they could take filters and they could use them in place of N95s. What happened when we looked at this network and saw what they were doing is they're doing great work. They had they could make these things. They had great designers. They were prototyping and testing very thoroughly, but their logistics system was a nightmare for them to use. These are actual screenshots, except for the one in the middle, of them swimming in spreadsheets. They were like highlighting rows and copying and pasting rows. And a lot of what we saw with all the groups that we talked to during this period of time is people were following this pattern of not having a system to facilitate these activities. So where are their demands? How much inventory do they have? How are they maintaining traceability? Just maintaining all this, you couldn't use an ERP like a SAP or something like this because, those things take a long time to integrate and they're expensive and they're not modular based on what you're doing. You have to change, like Kareem said, he had to change his manufacturing facility like overnight based on, the challenges he was seeing. So I'm going to blast through this really quickly because I know I'm a little bit low on time here. But basically what we did was we connected these nodes. So volunteer courier networks, supplier warehouses and manufacturing centers, and demands from people actually looking for PPE. And we created this in a week, basically. We used the software I just showed you to build a network that could facilitate their processes and enable them to produce materials quickly. So within 5 days, we launched this. And, you can just talk to some of the people who were running their operations saying, I don't know how we would have handled the quantity of these deliveries without it. Words can't express how much I love this system. I mean, it helped them do their job. Right? It helped them succeed. So here's a map of a few weeks ago of where we delivered to using this system. The green dots are our supplier nodes. The yellow is where we've delivered to. Here's just a few metrics. At the time, I guess it was 41,000. They've delivered, this is a little bit old. They've delivered, just Masks On has delivered over 15,000, doing over 1,000 a day. And then we're also working with other groups who are accepting donations and putting that into their inventory, connecting it to their demands, and so forth. The way this thing is kind of imagined is there's a single application people use. So they log into their cell phone, then they assign themselves a role within this network, whether they're going to be a volunteer courier or they're going to be someone ordering materials, or maybe they're managing a network of supply sites. You'll see here that what we're doing is we're connecting these nodes together using a common system that works with their other environments. And when someone basically logs into this network, based on the role they have, it's going to enable a subset of applications that relate to them. And all of these were adapted and changed. They're continuously changing because of the nature of the platform we have. And I'll just give you a little intro as to how like the flow of this thing works. But basically what happens is someone would log in and then, they would request material through like an Amazon-like view. And then that would go into a request terminal where the suppliers could view the demands and then accept those demands. Then they could process those demands. And then allocate inventory to those demands. They could process them through shipping by either going through like an Uber-like application we made, which enables drivers to log in as well and see which orders are in their network or in their area based on their coordinates. And they could say they're going to deliver those. And then it would relieve that inventory and transfer and fulfill that order. Or we could use, national carriers like UPS or FedEx. So this is just a kind of an overview of how the system functions and what we built in a pretty rapid time. And I imagine something of this nature is what we want to use in a future state. I think I'm about over time at this point, but I wanted to share that with you. And I think this is really exciting because there's so much capability in the future. We're going to have even more capability as devices become easier and more capable to get a 3D printer is like unheard of in the past, right? What's next? The more we can build, we'll be able to build in a distributed way. We should be able to unlock that instead of relying on these traditional supply chain networks. And I think that's it for me. Thanks, guys.
Thanks so much for that, Mark. You know, I'm really impressed with this logistic system that you've, in such an agile way, have conjured. It feels like you've conjured it to manage this demand with supply. But what I appreciate the most is that you've considered the supply coming from both the maker and the more professionalized fabrication services out there. I think that's quite significant and meaningful, because when we were planning this session, we wanted to make sure that we too would have the breadth of those two perspectives here. And I'm very happy to now be queuing in Golan Landsberg from HP, because I was actually quite impressed when I was looking for what big 3D printing machine manufacturer can we pull in. I was actually really refreshed, Golan, when I found this Notion page. I'm a big fan of Notion. We use it in Wikifactory to collaborate with the team and with our partners. And to see that HP themselves had also been organizing with their own subsidiaries and their own partners, how you would, in effect, start sharing the knowledge of the different designs that can be made on the ground, somewhat kind of like how the maker movement's been organizing. So over to you, Golan. I look forward to hearing what you've been doing in response to COVID in distributed fabrication.
Okay, thank you. Happy to be here. Actually, first of all, apologize for the field conditions here, and I hope it won't interfere. But I would say that the big HP kind of looked on our capacity printing, and I think we kind of harnessed most of our worldwide, mostly in the US and in Spain, fleet of 3D printers, mostly to use for ventilators parts and face shields. But actually what I like to cover is a little bit maybe different thinking that we did in HP Indigo here in Israel, which was actually not the trivial path for HP in terms of technology or distributed technology, but still, you know, kind of bring a nice and interesting scale. So I'll try to share. Okay, so let. We are a big audience of engineers and other scientists. We kind of, you know, thought, how can we do well for the for the planet in a way, and see how we can harness our capacity. And I will go to a process that we went through, which is called design thinking, which maybe some of you are aware of, and we use that to kind of see and you know, kind of consolidate our ideas to how and when we like to use our capacity. So a few days of ideas making and all kinds of, you know, technologies explorations. It took us a few days, about 5 days, after looking on different ideas that you can see on you know, on this funnel. We kind of narrowed down to 3 major things that we focused on, and today I'm going to talk about the face shields, even though we also had a similar startup on kind of face behind mask, which is the printed stickers that we put to.
Oh, losing Golan there.
We're bound to have technical difficulties at some point.
Exactly.
Do you guys get me?
You're back.
Okay, we're back. Sorry. So not sure where I was cut off, but I will just say that we narrowed down to the face shield thing, and when we looked on the 3D printing as a solution, we kind of we kind of suspected that it won't give us the right scale, and at the beginning of the process, we start to interview mostly doctors at the different hospitals in the country. So we went to about 10, 12 major hospitals, and we kind of interviewed them first for their needs, and then for the capacity they think is needed to, to answer their needs. And what we kind of come to is that we need to, in order to support those hospitals, because I would say, we like to support hospitals because they had the most affected interface with the disease, and we come to the conclusion that each hospital consume about 300 to 400 face shields a day, and in order to to support the 10 major hospitals, we need to produce about 3 to 4K units a day, which was, for three, it's not trivial to produce. Each one of those 3D printers can produce few tens of masks, and we needed few hundreds a day. So we try to look on different type of technologies to do that. And I won't go through all the different, brainstorming that we went through, and it's also in Hebrew, so no one can really read it. But eventually we narrowed down to some basic manufacturing technologies. We look on different type of mask, but eventually we came with what you see here. And this was actually very easy to produce. If you look on the components, they are both die-cut polymer-based parts, which is very, flat, easy to pack, easy to assemble, easy to, to clean, and we try to do something that we can produce in, in thousands a day. And this was our first prototype. You can see on the right, the first field test that we did, and eventually we produce about 2,000 of these. We start by cutting it by laser, and then we move to to a die cut. And the thing we did, we kind of collect feedback from the different medical teams that use it, and we try to improve as we go. So it was very fast, our design. So in a way, few of the things that we learn is how comfortable the face shields are, and whether they protect, kind of protection from the top. And okay, and we kind of moved to another version, which was kind of what you can see maybe here. It's more of a traditional sponge, rubber band, and face shields. And I think the major we try to distribute it to the, our Shield for All website, include all the production files and whatever one for a few hundreds of thousands, a big saver for the hospital in Israel. So I think I'm going to finish up here.
So, and unfortunately, there was a bit of technical glitches in there. So we heard bits and pieces, but we saw it all. And I think it's, you know, the importance of both the feedback loops and this design methodology has come up time and time again, whether it's in the work that you're doing and inside some of the large organizations that are supporting, and in the maker and maker movement. So there's just this constant iteration that is happening based on available tools, available knowledge, context, culture, all of those variables that come into play, and just continually iterating on what you have. So appreciate that very much. And with that, we will queue up I'm going to go ahead and queue up Mo here. And Mo, I haven't seen you in a while, but so Mo or Martin, based in Germany, and you hold a variety of hats, and I think a few new ones since the last time I saw you. You know, we had the pleasure of collaborating together in Warsaw last year, which is actually where I had the pleasure of meeting Tom as well from Wikifactory, around you know, continuing on the thread of building an internet of production, and what are some of the requirements to do so. And so there was a two-part event that happened. The first part of it focused on this alliance building and the larger requirements gathering, and the second piece was really around getting into the standards and how do we standardize data across a variety of different players in this space, so we can address some of the concerns that come up in earnest in a conversation around this, around security and quality maintenance and quality assurance. So Mo has now been holding the charge on a group that has continued to move from there, called Open Know-how. And with that, I will let you queue up and tell us what you've been up to in this space.
Thanks, nice for the introduction. Also nice to see you again. There have been so many things happening the last 1-2 years, and it's amazing also how to see how this practically evolves. So these approaches here. Yeah, so as you heard of the introduction, I've been more involved into this abstract side of the issue, and also how to embed workflows and standards into the system, because it's not just how to respond to the crisis, but also how economy keeps on after the crisis. And especially in Europe, there's some surprising interest about that. So how circular economy could be embedded right now, because it would be a great moment as the economy is having issues anyway, and how cooperation can work, not just in Europe, but worldwide. Okay, so I prepared some slides. As I came in last minute, that was rather a draft, so apologize for the quality, but I guess I'm pretty sure you get the point anyway. You all can see them?
Yep.
Cool, thanks. All right, so open source hardware versus COVID-19, the crisis response, and so an effective open approach for that. So our starting point is this global pandemic, and this means that we will need, for instance, in India, 30 million ventilators, and we will need them by October maybe. So when I realized that these facts, some questions arise in my head, stuff like, who can actually do that? I mean, in terms of development and also the production capacities for all these ventilators, who will maintain, test, update, certify, whatever them, once they have been produced and developed and deployed, and what actually happens with them afterwards and with all these production capacities. So this is the conventional industrial approach doesn't really deliver satisfying answers to those. So I had a good time pitching an open approach. So share the challenges, share the knowledge, meaning everything, not just the the design files, but also the research and everything which is going on in this area, and then solve the pandemic together and everywhere and sustainably. Cool. So distributed design is the buzzword of the hour. It all starts with a hardware design. The hardware design is sort of the source code for a piece of hardware. And whenever I say hardware here, I mean not just the full ventilator or a fully working machine. It could also just be a module, something like a valve, for example, which is inside a ventilator. So it doesn't really need to be developed, produced, maintained, whatever from one individual company, but just anyone. A lot of pieces put together. So we have the hardware design. This is getting produced by anyone. Then it's getting used and maintained. And that's all made possible because the hardware design itself is open. So everyone gets the information which is needed in the chain, and I have individual stakeholders or different groups that are unable to do that. We also have continuous research going on the issue. So we are getting two feedback loops, one from the production, usage, and maintenance side, so the side of the deployment, and then also some research input, which leads to updates of the hardware design and then to the physical artifact of it. That's all being done by the community, and the community is not just an ominous character in the cloud. It's an ensemble of individual teams, manufacturers, users, service providers. So we see first we have a lot of interfaces to manage, and the center of everything happening is the technical documentation. So our approach to that, to handle that, and that may be a pretty German approach, but we felt we need some standards. So the two big things that we came up with were covering fundamental issues of the technical documentation, which is one thing, having it complete, because most of the hardware designs we found out there, which are not electronic, but also mechanic or mechatronical, are not complete. So they're more DIY if you can just build them, but if you want to enable these feedback loops, you also need to modify them. So you need the original CAD files for all of the parts, and sharing these design files is a nice thing, but you also need to find them. If no one knows that you published that design, you will need to reinvent the wheel anyway. So for effective design reuse, we will need some standardized metadata as well. So we find what you actually need. And we also did things like defining a community-based attestation process for official reasons. That's interesting here, but to build a bridge to industry, public authority, and that's it. All right, and now that could work in practice. What that means is that the technical documentation is published somewhere. Alone in the English-speaking area, we have more than 80 different platforms where I could upload hardware designs like Wikifactory, Hackaday, Thingiverse, and so on. And so from that platforms, we can get the data attached with standardized metadata, so someone else is able to understand and read it and filter it. This is collected by quarters and put into a Wikibase instance. That's what I'm working on at the moment. So connecting all these dots, all these different hardware modules to one big graph database. So people, and an open database, of course, so people can, explore which hardware exists in a certain field of technology, which hardware is compatible to others. What? Sorry?
Oh, hearing you again. Apologies, Martin.
Okay, great. So a big graph database connecting all these open source hardware modules. So we see which modules are compatible to another, and also which modules exist in a certain field of technology. Yeah. So that's more of an outlook, what can be done with that. Yet we have this lead spec, and we also have the open knowhow standard for the metadata. We already created a sample set of data, so it's still in an early phase. We're testing that. So our aim is to create until the end of summer 500 different projects, or create the metadata for those projects, and then test it in this graph database. I hope, but while we are starting with COVID-19 projects, so I hope this can deliver value within this crisis already. But as I said, that's rather a thing for after the crisis, for how this collaboration can work afterwards. But yeah, anyway, these collaboration methods can be used already. Yeah, that's it. Thanks for listening. And yeah, for those who don't know me, I like very uncomfortable questions because they make the projects better. Thanks a lot.
That's such a great quote, Mo. I love that. I hope that the Q&A will reach that high bar that you set with uncomfortable questions. And you know, it's absolutely fantastic because Martin is in a EU program with us at Wikifactory that is pushing for exactly extending that kind of thinking for collaborative engineering. And we've just actually submitted a bid for another program specifically for COVID response. And actually, this is the perfect cue in to Tom, our CEO at Wikifactory /CTO, because in fact, some of the threads of thinking, Martin, you know, we're so aligned in this aspect of sharing that documentation, that data from a values perspective. I remember when we first started thinking up of a collaboration platform that people could share hardware projects on Wikifactory. And of course, with our repository, we needed to be able to view files. But we saw that everywhere in the web, everyone was just sharing STL files. And STL files is like trying to send a PDF to someone and hoping that they'll be able to collaborate on it as if it's a Word doc. So of course, you know, we had to release a viewer where people could view CAD formats, even proprietary file formats of, you know, 30 kinds. That was actually something that Tom decided on. So I'll cue you in, Tom. It's great to have you here.
Thanks, Christina. Yeah, so first, great to hear about all of these different aspects and approaches to things. I'm going to kind of be quite brief, hopefully, and try to ask some of those difficult questions in a way, just to get things kicked off. So, but yeah, I mean, it's great that we've like Espacio Open is kind of representing a community aspect of and a kind of distributed production in practice approach, and then Tulip from a software perspective, HP from a hardware perspective, and then Martin really looking at from like a very deep standards and academic perspective. So I don't feel like there's a huge amount for me to add. But briefly, you know, we launched Viral Response when all this kicked off as a way of kind of trying to create a dedicated platform for the open hardware designs for COVID-19. We've always been trying to work on distributed manufacturing for the last years at Wikifactory. And hence this kind of collaborations around Internet of Production, and with Martin on the EU programs right now. We're working on multiple partnerships to, I guess, you know, so the big question for me is how do you really do distributed production and maintain quality? How do you do quality testing, quality assurance, particularly as products are being customized, hopefully to local needs? So this is kind of like, you know, I guess the elephant in the closet with regard to distributed production, which I think we all need to kind of think about how we can address really. Yeah, we're working on an open hardware fund with a number of different institutions. and a few other attempts to basically prototype out that process. So how do you create a design which is well enough specified that people can produce it in different places? Some of the challenges there are that often the machine code that we actually print from or produce from is being generated on a desktop, isn't sitting in a cloud system. We're not collecting data with regard to that. Those particular designs and all those particular machine code and machines combinations, if we were collecting that data, then at least we've got would be some steps towards being able to ensure quality in a distributed way. So Martin's work on the DIN spec is beginning to address that. I would say by addressing what would be sufficient documentation and specifications of a product to be able to reproduce something, but the level of accuracy we can take that to is going to be higher and higher as we start to move towards reproducible build code. Like one very technical point that I would like to make there is that we still operate when it comes to machine code on the basis of G code or similar, which means that we specify like how a 3D printer, a specific 3D printer's axis is going to move, and that's entirely dependent on the scale of the 3D printer and the instruction set of the 3D printer. I think it would be interesting from a standards-based approach if we could head towards specifying what has to happen to a workpiece rather than what movements a machine needs to make. And the standards developed actually in the I think in the 90s for this as extensions of the STEP standards. There's a thing called STEP NC, which understandably for the time probably disappeared and died and was never really adopted. But I think that it's kind of getting to the time where that'll make sense, and where interesting to have a representative of HP here, because I think machine providers need to start thinking about how they can standardize that more and more. And if some machine providers take the initiative, then others will almost be forced to follow, and that will make a massive step towards being able to actually do reproducible builds, which in the end is what's necessary for distributed fabrication, as far as I understand it. Obviously, the advantage if we manage to do this is that we can get to like a circular economy, or at least it facilitates part of what's necessary for a circular economy. And if we can start to be able to adapt designs, I think the other thing that would be extremely helpful is if we started to specify designs in terms of the requirements of components and materials, rather than in terms of the exact components and materials, because then it should be possible to, in a more kind of verifiable way, swap out a particular material that's used to make a product in a local context, and have a good at least chance of it working. It's like one step in the right direction. So yeah, I mean, throwing back the question to you guys, given that we're also talking about short term here, what are the for me the question is like what are the things we can do in the short term to make distributed fabrication possible in a reliable way? Of course, we're dealing with like high audit requirements when we're talking about medical devices. I believe personally that we're going to move towards thinking beyond medical devices and PPE and much more about product innovation at this point, and the new products that we can create to upgrade the built environment and reduce the chances of transmission. But I'll leave it at that and look forward to discussing with everyone. Christina?
I'll just I'll add on to your question, because you use the phrase elephant in the room, and hilariously and unsurprisingly, we were all doing a mind meld, because that was the question that was going to get posed. I think you mentioned mention the one, right, around the quality assurance. And I think I don't think you'll find much disagreement in this group. I'm also curious to know, you know, we're all coming at this from different angles, and I think we all know that you know, the process that we're in collectively right now is not new, right? It is certainly at the height of media attention, and it is certainly affecting at a global scale, and the reactions that we're seeing in this prototyping of PPE and these connections between the maker movement and large manufacturers is not dissimilar to you know, what happened in the Ebola crisis not too long ago. And so I'm curious, when we talk about, you say, elephant in the room, what are the elephants in the room, I guess? Like, what are the things that we are not talking about when we have these conversations, and what are we missing, right? So Mark, you and I had a conversation around you know, different cultures and contexts, and whether some of the file formats were accessible to folks, and if the machines are accessible. And I was delighted that you know, PPE logistics has the mobile component to it, because it allows people to select their role from a mobile device. So I think there's a lot of different pieces, but I'm very curious to know from this group and saying, well, what are we not talking about? So that to Martin, to your point, we can ask the hard questions and try our best to answer them as a group.
Well, in terms of the standards things and addressing the elephants in the room, I feel that it's pretty clear that what happened during this pandemic is that we stepped in because plan A, which is the government, and plan B, the companies, weren't ready. And you just bought everybody some time until the formal structures of manufacturing could take over. And we basically did the first draft of the designs that were going to be later manufactured by large companies and government procurement. And I feel for that the maker community and the Fablab community are already quite ready. I mean, we are a network that designs and manufactures and innovates quite fast, and faster than any type of planified innovation process. And then we have global reach because we're everywhere. The thing is that this specific moment didn't, I mean, the fact that we can tackle this problem doesn't mean that we can create an incentive model for this to scale to other parts of the process, you know? Because if there's a business model behind it, eventually somebody will figure out to make a business out of it, and it will be sustainable. And that would include also including the quality and standard process into it. And there will be, you know, validation process as in every industry. But what I'm more worried is, what do we do with problems that don't have a business model actually, but need to be solved? You know, like how do we get, you know, equipment and or any other type of things that we should have to be forced to manufacture in case of another crisis of emergency? How do we tackle that without having a business model that can back it up and create the proper incentives for the machine to make it work and solve that problem? And I think that that's not solved yet. And also in the open source community, we still have this problem that most of the biggest contributors are either already working for an institution that is paying them to do open source divulgation, like in academic or research, or if you're in software, where it's basically, you know, it's your badges that are gonna make you have a good job or not. But there's a lot of open source communities that are running on faith and heroism, because we still don't have an incentive system to give rewards to people who are really adding value to society with their designs and their solutions to problems that are everyone's problems. And once the problem becomes less visible, well, these people still have to pay their bills, and they have to find time to keep doing the superhero thing while surviving, because societies cannot still figure out a way to reward them enough so they can keep doing that important thing that solves so many problems for everyone. So I don't know. I leave that question open because of course I don't have an answer, but I think it's linked to the conversation we're having also.
I think the thing we're not talking about, like the elephant in the room here, is like the N95 example, right? My cousin works in healthcare, and she messaged me and said, Mark, I need a 1078 plus, which is some version of an N95 or whatever, right? And despite the solution that I shared with you and the solutions we're talking about, that's not available. You know, so like we have these capabilities, we can 3D print things, we can make masks, we can create the supply that we can create, but where are we looking at our demands and where are we understanding what they actually need? Because that's the litmus test, right? When someone in healthcare says, I need this mask, and I'm holding one, like there's one right here, right? This thing, like this shouldn't be that hard to make. Who's trying to resolve this problem? And how does that person who wants this thing know that I have figured out how to make it, you know? And I don't know that, like, I feel like the elephant in the room is that we make what we can make, that we think there is some demand for, but we're not making what they need right now. And we're still relying on 3M to produce millions of these things, and they're still going through their existing channels. So I think that's the elephant in the room, and the challenge to us is to recognize, honestly, the demands that we see, and then try to come up with solutions for them, and then let them know that those solutions exist, and then give them a network where they can actually be fulfilled.
Sure, keep on.
Sorry, who is that? I interrupted.
That was me, Mo.
Please, Mo.
Okay, I'd like to add something to the business model question. I really like this question because it goes right into the heart of the open source approach, and it shows the gap between how society could work and how society is working. And actually, this issue has been addressed already by society because we have some shared issues which you cannot, there are some areas that don't produce a product that you can effectively sell, like education or health or an infrastructure of streets where you can drive around. So that's usually where public money goes. And open source is building an infrastructure of free technology, which everyone can exploit. So in the software world, these open source modules fuel the digital industry, which uses these free modules and builds them together. No one writes software from scratch, so they copy that together. And so it should be from public interest to do that. And when we look into the business model issue of open source hardware, the actual issue is not producing or maintaining hardware. That's all service that can be paid, and it is paid when I'm a classical company. The actual issue are the development costs, because that is actually done by the community, and no one is paying that, because that's what we deliver as a free infrastructure. So what I was looking at is how we can access the public money on the short term. On the long term, we can have like great visions what happens in 20 years, but what can we do now? And a very good entry point is research. So we already mentioned that most of or a lot of contributors or drivers in the scene work for some institute that can access the money to finance a certain thing. I just want to give this as an idea. So collaborating with the public authority, like in Barcelona, the Fablabs, or with research institutes, may be a good workaround for the moment to cover this need. And on the long term, we may want to rethink how businesses work. So thinking of distributed enterprises so that the development work is shared across the stakeholders, things like that. Yeah, that's why I'm doing so much lobbying, but this will take a few years more.
I can agree with more with all the points, actually, starting with the aspect that, in effect, it's not just medical supplies. This agility that Kareem, you were mentioning, of the maker movement, to respond and produce one-off, products like you mentioned, Mark, in an ideal system where we can match need with the capacity to fabricate those one-off customized products on demand. That agility of our network is really powerful to think of, to be honest, the 1,000 objects and products that we're going to need to return safe to work, to retrofit our homes, to retrofit our offices. Actually, I'm going to do a shameless plug. Wikifactory is hosting with Snapmaker, a 3-in-1 digital fabrication machine, a challenge to redesign toys so that they're safer to play. Because it turns out that with copper, the virus only lives on the object for a few minutes compared to hours. So we're going to have to rethink a ton of objects that we work with, and that agility no one can beat but the network of designers, engineers. And we can be a lot faster if we can share our documentation and build on top of each other's work. And I completely agree with you, Martin, the importance of public funding. It's interesting because one of our top projects that I think you're kind of linked to, Martin, Corolla, that developed a container box for micro mass manufacturing of face masks on the ground, is now closing. It just got bought. But there's this sister project called Curopods. And the roots of that project was open source. And now Curopods potentially will embody the open source version of Corolla. And it's interesting because I think, when it comes to business model, I don't know if I agree with you, Kareem, whether it is about not having a business model. I think, software has proven that there are ways to build business models around open source. At the end of the day, my elephant in the room right now is I'm a bit concerned of the fact that we have been so volunteer dependent. All of these networks have just popped up around the world. Like, for example, one of my favorite, TMOSV, thousands of engineers and designers working together on medical supplies, and not just the ventilator, but the dozen medical supplies from dialysis machines are also needed. They're problem solving in a fantastic way, but they're volunteer driven. And now the decline of volunteer efforts is real. And therefore they're having to see how they migrate or transition to a situation where they won't have that leverage of their volunteers. And that concerns me because for many of these designers, it's the first time they've engaged with an open source design project. And you would want to create a learning curve or a way for them to keep engaged and actually to build upon the existing designs. So for me, that's what I'm interested in. And for me, the way to resolve it partly is, the people who are involved in these projects can prove to be, agile problem solvers, at the end of the day become experts in that process. And that's not what actually has been told. It's incredible the media attention that all the face shields and the masks have received in the last few months, but they're missing the key point that exactly they've been more agile than anyone else. That exactly the plan A and the plan B didn't work out, and hence the agility of the designer and engineer community just was faster than the rest. But we need to find ways so that these people can be incentivized, that we can reward them. And if they are experts, well, they can be commissioned. How can we, I don't know, I think this is a question to all of you, because maybe it's not so on and off. Perhaps it's not on and off in the sense of either it's grassroots or it's corporate. What can the corporate network learn from the maker movement or from the grassroots movements? But what can the grassroots movements learn to actually build sustainable models that are not exploitative or extractive, whereby the incentive models live at the network and ecosystem level?
I like this argument a lot. I think that's a really, really good point you bring up, because I'm seeing that too in the network that I was sharing, is that the volunteer, the volunteer basis level is reduced, right? And it seems natural that the answer would be to make this an economy of its own, where people get paid for participating. So if you were to deliver something, for example, within this network, you would get paid. And this is not like an unusual idea. I mean, you see, like I mentioned, Grubhub, right? They pay their drivers, and the same with, you know, I mean, we like it or not, we operate on an economy, you know, capitalist society. So like this is a good incentive, I think, to use to motivate individuals to perform activities. It doesn't have to be completely like grassroots, but the system doesn't exist, I don't think. Like if I wanted to volunteer to build something, you know, I would love to say, yeah, I have a printer out, let me just make some money off of it. How do I do that? You know, I've got some extra time. Maybe I was laid off or something. I want to use my car to deliver, you know, copper to this toy manufacturer down the street, but I don't know the copper is on this street. I don't know the manufacturers on that one, you know? So, I mean, if you could, as far as designs go though, you know, I would think that person would also want to be like, get some sort of percentage of the people who actually use the design, you know? So like there's some sort of, I'm not an economist, but I imagine that money plays a role in motivating people in a sustainable way to like participate.
You think, Mark? money plays a bigger role than perhaps we all would like.
So like, I would think we could use that, you know, as long as it still holds some value by, you know.
Yeah, I just quickly want to chime in, and I think a lot of actually what we're talking about is, and I'm not an economist either, but the challenge is that we're, you know, since we have a couple points around a couple of points that have been made around economics and circular economies and incentives from the very beginning. I mean, what we're talking about is outcome-based financing and outcome-based incentives. And the challenge is that the financing work that's happening is not, and where the money is not flowing in that way. So then it can't flow down to the people who are actually solving it on the ground, right? So there is this, the incentives are skewed, to your point, Kareem, and the incentives are skewed towards the businesses, to the entrenched businesses that are doing this, not to the open source and the grassroots. And I don't think it's an either or. And Golan, I'm curious to hear from you on that front, because clearly you've taken some learnings from the maker movement and the process and methodologies that you've been running, and you are also in an organization that has enormous reach and scale. So I'm curious to hear from you as to how, to Christina's point, how these networks that are all looking at, going back to the elephant metaphor, that are touching different parts of the elephant now. How do we come together and build that connective tissue and plumbing, if you will?
Yeah, I think that, for us, first we kind of got some lesson on agility and lean production and design. So it was a big learning for us, and of how fast you can ramp product design and scale up. And we do machines that take years to design and months to build, and we needed to come with something much faster and to scale up it in a much faster way. Of course, simpler products, but still, I think it was a big lesson for us as a the technology company and design team. And it was also interesting to see how we the distribution to hospitals and all the the feedback cycles from users was a major learning for us of how fast you can improve and grow your in a way product. And for HP, we did everything totally voluntarily. We used the company resources, but we also used the people's time. And I like to maybe to point to the finance or financing or economics of this entire thing. We were able to produce one face shield in less of $1, or cost of manufacturing, and you could probably do good business with that without using the people's stress condition, and do both, do some economics, but also bring society relief or society benefit, trying to do both. So it was an interesting this experience for us. Same goes for the 3D printing. It's HP look on 3D printing not as a prototyping kind of thing, but more of a scale, kind of changing the mold injection part. It was interesting, because it was our first challenge to address high volumes with our 3D technology, and I think I don't want to say that we made it, but we had a lot of learning of how we scale up production from few thousands to few millions or few hundreds of thousands.
Thank you so much, Golan. Because actually, we're going to be wrapping up in a few minutes, but I just can't contain myself, guys. And this cues Martin one last time, Martin, because we see that you've shared the documentation, Golan, of how you design your shields, like the maker movement, the grassroots, Fablabs, makerspace movements have done so. But this is for me, the most important elephant in the room. I said one, but I have actually the most important one that I reveal now. And that's actually that, design isn't prepared to be replicable just quite yet, from my humble perspective. Unless we share that documentation, unless we have the standards to share how we fabricate our designs properly, it's not quite there yet. You'll have, a design won't be made to the same specifications when it's a different machine with different materials, even different environmental data in terms of humidity can totally entirely affect the result of a 3D print. And this is where I value the work that Martin is doing. Martin, I know you're part of open source ecology, and you've lived that firsthand. How can we better document? What is the role of documentation and meta standards to pave the way for replicability, for that matter?
So can you specify the question a little? So in terms of ICT or the content of the documentation?
Yeah, it's true that I didn't frame the question just quite right. What is the most key information that is actually lost at the local level that is key for the replication of a product?
So many. So it starts with, do I actually need this module? Do I have the machines for it? Do I have the software to look into the design files? So there's a lot of information that can be key for a specific manufacturer in a specific country. It doesn't really need to be the legal barrier, because I don't really know who was it saying that in this crisis, it's not quite interesting if this particular design has been CE certified or something. I just need something to save some lives. So the key question is if I can fabricate it or not. And so, yeah, from my perspective, the fundamental question is how fast can I access this information? So the metadata is key from my perspective, and how matchmaking works on an automated way. That's what I believe at the moment. So maybe in a few months, I think differently when the system works out, and then I don't know, humans are smart, but that's my current approach.
This sounds, if I can weigh in on this question, being a manufacturer, we would have a design specification from our design and engineering team. And the specification would say something like it must meet this dimension or this torque or this whatever, right? Mm-hmm. But that's different and distinct from the manufacturing processes. And those are going to be changed naturally. And you could do those in many different ways. You could automate, you could do it manually, you could do whatever you want in order to achieve those specifications. So in order to, what we're talking about here is what level of manufacturing production and process control, what's the manufacturing procedure documentation that goes along with this? And is that necessary? And in what cases is it, in order to maintain the process variation? So you have like the quality of the, like there's the quality of your product and how many defects you have per million and these sorts of things that weigh into the level of production control and processes you use. You know, it's a different document altogether than is the design intent and the specifications. And it's equally important, and that's like manufacturing engineers do this all the time, or process engineers, for example. And it all comes down to process variation, really, and the quality of the product you're producing.
Yeah, what you're describing is how modularity can work. What we addressed is what needs to be delivered in the documentation so that others can use it. But how you can build a modular system is another thing. Yeah. So we didn't specify you need to have this dimension for this part in order to be compatible with the other, because we cannot foresee that. And standardization is also kind of a slow process. So when we have the standard ready, the actual technology may be outdated already. So what we did is building the infrastructure, like a common base. And then my approach to that question was when seeing what others used as a module for this specific use case, I can sort of assess the compatibility of it. So in the end, always humans will look into the designs and see if that actually matches there. I didn't really think I could replace this mechanism with a computer system. And also if that works in practice. So if it works, people are more likely to use this module in their machine. And I can see that if they do this. And so I get sort of a map of things that work together.
Interesting.
And if we want to have, let's say we want to build a ventilator together, a system that is just a broad idea. We could have one repository where we set up the interfaces of each modules. So here's a module that creates the air input or something. So it needs to have this dimensions, the screws there, and this software, whatever. And there's the other stuff. So it's just a skeleton of technology, and then all the different communities can work on this or that module. But everyone is referencing to this skeleton, which can be an individual repository. That's just an approach how I would do it from an engineering perspective, but people come up with amazing ideas, and I didn't want to limit that.
You know, Christina, if I may have one more comment on that. So at least the way we look at it at HP, we actually look at it as a product. And as an engineer, you know, as a design engineer myself, we actually produce a production files for each one of the parts, drawings, dimensions, assembly instructions. And, you know, if we were to use any code or DXF files or any production files, we could, you know, deliver that or share that as a, you know, production instructions. This is how it's actually made in our shared site. So maybe this could help in, you know, duplication and getting the same product in different areas in the world.
So what I'm hearing is that there needs to be an entire one of these sessions focused on standards. That's enough content for one in of itself.
And we probably need more creativity also on testing, definitely, you know. Also, the pandemic was also a good way. I don't know if you saw this video by an Egyptian pharmacist that showed you how to test your masks. So you would basically take a lighter and then the mask, if you can turn off the thing, it means the mask is not good enough and you have to throw it away because it's not filtering it. So hacks like this were super useful during the hard days of the pandemic. It would be a great open question to figure out how to make the quality testing hacks community grow bigger as the challenges that we have to tackle also go in that sense. And about the open source models, Christina, don't misinterpret me. Of course, there's open source business that work, but I also feel that there's a lot of things that add a lot of value that will never have a business model. And I would like for these people to keep doing that amazing thing. I still don't have an answer for that, but I guess we still have a whole century to figure that out.
Oh, that's such beautiful words, Kareem, because I couldn't agree more. I mean, the truth is, you know, you use the term trenches, because at the start of it, I also felt like, you know, we were luchando a distributed, you know, war in effect. I mean, everyone who put their time to design the shields, to produce them from their, you know, quarantined rooms, we were giving back. We were also feeling useful, and that experience no one can take away from us. And we should, you know, make sure that that culture remains. You know, I completely agree with you. I really enjoyed this whole session. Everyone has brought such great perspectives to this session. I would love to, sadly, I have to call it a wrap up. I could speak about this nonstop. And, you know, coincidentally, we just launched a poll with some of the topics for the forthcoming sessions. You'll see the aspect of testing. I couldn't agree with you more, Kareem. You know, Madelynn said that we should have a session about standards, but logistics is also, you know, key. So I hope that we can continue this conversation. I think I might hijack next week's and say it's going to be about humanitarian relief. I feel that now that, you know, some European countries are going out of lockdown, that we might forget that, you know, many countries haven't even reached their peak yet. So it's an important aspect to consider, not least in terms of the sustainability aspect with all the waste that we're producing. Is there a way of, you know, someone mentioned circularity. You did, Kareem. How can we make our supplies not, you know, in fact, circular products, reusing waste, or at least local materials? These are the questions I hope we can cover in the next roundtables. But this one certainly is a very memorable one. Thank you everyone for joining.